So on the warm-up, you should have first factored out an x. That leaves you with x squared plus 4x minus 12. All of that is greater than 0. Then you can factor that trinomial. So that gives you x plus 6, x minus 2. All of that is greater than 0. What that tells you is, that tells you you have zeros at 0, -6, and +2. If you would set those factors, these factors right here equal to 0. So you'd cross over the x-axis at 0. 1, 2, 3, 4, 5, 6, -6, and +2. It has an odd degree with a positive lead coefficient. So that tells you that the ends are going in opposite directions and that actually the function would look something along this line or along that way. Okay. Again, not concerned with how high it goes or how low it goes on the two humps, just concerned that it crosses in those three positions. Okay? What this is asking right here is it's asking when is the function bigger than 0. So if I'm looking at my graph, that would be when I am above the x-axis. Well, I'm above starting here, then I stay above and I finish being above right there, then I pick back up being above there. All of those coincide with the zeros. So in interval notation, I would be above the x-axis. It's not an equals part, so I'm not using brackets, I'm using parentheses, from -6 to 0, unioned with from 2 to infinity. If I would do that on inequality notation, then that would be from -6 is less than x is less than 0, or x is greater than 2. Use the coordinate plane sketch in order which values simplify. So that in red is what we are looking for both in inequality and interval notation. Yes, ma'am?
Would it be like wrong to like switch, like where you put -6 and 0 and then put greater signs? Like is that wrong, or is it just like opposite?
So like this you're saying? 0 is less than or is greater than x is greater than -6.
Yeah.
I'd be okay with that. It's not very conventional, but yeah, it works. As long as they both are switched, yes. Okay. Good. Out of the textbooks today, okay, we're going to be starting on page 408, and we're going to be talking a little bit here about different ways of analyzing functions. So, before we even start with this, know that when we are dealing with interval notation and our equation, our function, if you will, has less than or greater than, that is when, in the interval notation, we are using parentheses. If we are greater than or equal to, less than or equal to, and we are in interval notation, we're using brackets. Okay, some number bracketed with some other number. Okay, so just so you know that. Okay, so Samson, Kaylee, Paco, and Sal are each solving the exact same quadratic inequality that is right there. Okay, that's the inequality that all four of them are solving on the next 3 pages. Well, this one and the next 2 pages. Okay, so Samson here goes through and Samson graphed both sides of the inequality. I know that Samson graphed both sides of the inequality because Samson tells me right here, I graphed both sides of the inequality. Okay, so Samson put 2 graphs up on one single graph. So he put 2 functions on one graph. Okay. Now, based off of the inequality sign, right, or the inequality symbol here, okay, in my original function, Samson is looking for where the his second function is below his first function, because that's what it's telling me. Negative 24 here is greater than this other one. So he wants to know when y sub 2 is below y sub 1. So he looks at it and he says right there. Okay? So he drew vertical dashed lines at the 2 points where the graphs intersect. He determined from the graphs that the values of that generate less than negative 24 between negative 4 and negative 3. So therefore the solution is that. We could also say in interval notation, because we're dealing with less than, we're going to use parentheses. We could also say that. These 2 lines are saying the exact same thing. Negative 4 is less than x is less than negative 3 is the inequality. The interval is negative 4 comma negative 3. Okay? Any questions on Samson? Okay, he's pretty straightforward. Let's look at Paco then. Paco is on the next page. So Paco is on page 409. Okay. Paco added 24. Remember, our function started with negative 24 is greater than 2x squared plus 14x. Okay. So Paco added 24 to both sides because he wanted one side to be equal to 0. Then he graphed that inequality. So really what Paco is graphing here is Paco is graphing 0 is less than, or excuse me, 0 is greater than 2x squared plus 14x plus 24. Okay. So now what would Paco be looking for? What would Paco be looking for? Above 0? What would Paco be looking for? What do you think, Nick? What's the function saying? Nope. This is the one that's our original function. This is Paco's over here. Okay, so what's Paco looking for on his graph? Below the x-axis. So Paco here is looking for stuff below the x-axis. Whoa. Okay, so Paco is looking for everything that's below the x-axis, which happens to show up right there. He draws vertical lines where the graph crosses the x-axis. He then determines that the values there are -4 and -3. So therefore, his solution is the same. Okay? In interval notation, his solution would look like -4, comma, and -3. Right? Okay? Explain why Samson and Paco's are different, why the graphs are different, yet they generate the same answers. Okay? Why they generate the same answers should be easy. Because it's the same problem. Okay, they're doing the same problem, right? They're just doing it different ways, right? Did both of them get to the answer? Okay. You guys ever been to Milwaukee? Yeah? Is there only one way to get to Milwaukee from Wausau? No. Okay. I think I've been to Milwaukee, well, many times in my lifetime, but from Wausau, I think I've traveled maybe 7 or 8 different ways. Okay. Not all of them the easiest. Okay. But started in Wausau, ended in Milwaukee. Okay. All right. Many different ways to get to the solution. Okay. So, part B says Sal didn't do it right, but let's look at what Kaylee did. Kaylee remembers from solving linear inequalities way back in chapter 1 that she can treat the inequality as an equation and solve it. So she found, what she did is she set it equal to 0, solved it, found the zeros, then put the zeros on a number line and tested points in each of the 3 zones. Okay? Because right here was a 0, right here was a 0, so she tested one here, it didn't work. She tested one here, it didn't work. She tested one in the middle, and it worked out. So therefore she knew that her zones, she had 3 zones at the start, got rid of 2 of them, so the only section that still satisfied was that one. Her interval would still be -4 to -3. Okay? So it would still work out. Okay? You tell me what Sal did wrong. So what's wrong with Sal? What do you got, KG? He's got to get it equal to 0. If he's using here the 0 property, the 0 product property. Which is what Kaylee used over here. Okay? This is all 0 product property work. Okay? But what did Sal forget to do? You forgot to get it equal to 0. Okay? It's not called the negative 24 product property. Okay? It's called the 0 product property. So this was not so good math. Okay? So he didn't do it right. He wanted to use the 0 product property, but he forgot one key component. Okay? So what I would like you to do now is I would like you to turn to page, it's actually the next page, it's 411. It's number 2 on page 411. Okay? And I would like you to solve that using any method that you choose. I would choose either Sal, or no, I wouldn't choose Sal. I would choose Kaylee, Paco, or what's the other guy's name? Samson. Yeah, I would choose one of those. I wouldn't choose Sal. So if I do it Samson's way, I have to graph 2 functions, right? Okay. So my first function is 18, so I draw a line straight across at 18. My second function is 3x squared plus x. That's a parabola. It's got an a value of 3. It's got an a vertex at 1/3, negative 1/3. Right? Yeah, 3x plus 1. Yep, negative 1/3, comma 0. Okay? And then left and right 1, up 3. Left and right 2, up 12. Left and right 3, up 27, etc. Okay? So we got that. Then we find those intersection points. Now, on a graph, you kind of got to guess those, right? Not the easiest ones because they didn't intersect right at specific points. Okay? I did mine on the graphing calculator, but in either case, we got that. Okay? Paco's way, we get this function. We set it equal to 0. Okay? And then we're looking for that. Now, in Samson's way, because of how this problem is set up right here, okay, I am looking for where the function, where the red is above blue. Paco's way, I'm looking for where black is above the x-axis. In Kaylee's way, okay, in Kaylee's way, she set it equal to 0, solve for her zeros, okay? So in any of the 3 ways, the answers that we should get then in interval notation it would be above, so that would be from negative infinity down to negative 2.62, and that's bracketed because of the equals part, and then from 2.29 to positive infinity. Inequality, that would be x is less than or equal to negative 2.62, or x is greater than or equal to 2.29. Okay? You can get those numbers actually by doing it Kaylee's way, if you don't have a graphing calculator. Okay? Questions on that? Okay. Oh, come on now. Number 3, I want to say, is on page 413. We're going to do part A. If you want to use a graphing calculator, you can use a graphing calculator. If you want to do it Cayley's way, you can do it Cayley's way. Okay? But I want you to solve number 3. So if I'm looking at Samson's way, what am I looking for in terms of this problem? Samson's here in green and pink. Based off of my problem, what am I looking for? Andrew? Everything that's below -5. Alligator needs to eat the bigger number. -5 is the bigger number, so I'm looking for everything here below the pink line. If I'm doing it Paco's way, what am I looking for? Same problem, different ways. What am I looking for if I do it Paco's way? Below the x-axis. I hate it when it does that. So everything below the x-axis. All right? So in either case, my answers in interval notation are -infinity all the way up to -3.25. Did it again. And that is bracketed along with from 0.577 to 2.67, and both of those are bracketed. Inequality of the exact same thing would be x is less than or equal to -3.25 or 0.577 is less than or equal to x is less than or equal to 2.67. Yes? Okay. Now, we could do B here, but I want to actually talk first about number 4, because there's a problem like number 4, actually 2 problems like number 4 on the yellow homework for tonight. Okay? Average blood sugar, also known as glucose levels in a person's blood, should be between 70 and 100 milligrams per deciliter. Okay? 1 hour after eating. A person with type 2 diabetes tries to keep the glucose levels under 120 with diet and exercise in order to avoid insulin injections. Glucose levels of one individual over the span of 72 hours. Okay? Over the span of 72 hours, which means what's the minimum value that we could have here what would the minimum be for this study? 0. What would the maximum x value be? 72. Okay, so no infinities in either way. 0 is my farthest on the left, 72 is my farthest on the right. Okay, so here would be then my function. Okay, part A. For what hours were glucose levels greater than 120? So we would graph our function and we would probably do what? Which way would be best? Paco, Samson, Kaylee, what was the other guy's name? Sal? Which way is best in this particular case? Yeah, definitely don't say Sal. Which way do you think would be best in this one? Samson graphed 2 things. Paco graphed 1, combined them and graphed 1. Kaylee solved it for 0. I would go with Samson here. Because you graph your function, right? And then what are you looking for? In part A, what are we looking for? So we're looking for it above or below? Above 120, right? So when B of t is above 120. For part B, what would we be looking for? When BT, I don't know what BT is. B of t? When B of t is below 120. Okay? Alright? What I'd like you to do now is I'd like you to do this one, B. Samson and Paco end up being the same way on this one, right? Why? Why are Samson and Paco the same method?
Because putting in 0, which is the x-axis.
Even more than that. How's the problem given to you? How's the problem given to you? What, Jacob? Already set to 0, right? Yeah. So it ends up being the exact same method. Okay? If Paco graphed the line y equals 0, you're not really going to see anything because it's going to be the x-axis. Okay? So we're good to go there. Okay? The problem is saying 0 is less than, So I can't use brackets because it's just less than. It's not less than or equal to. So I need to use parentheses on my interval notation. And the function needs to be bigger than 0. So I'm looking for where the function is above the x-axis. And it's above the x-axis from -1 to 0.5 and from 2 to infinity. Okay? Yellow is your homework tonight. If you took a calculator, make sure it goes back into the correct spot.